Image interpretation. Types of image interpretation. We have studied two major types of remote sensing data products, that is pictorial and digital. The pictorial data products such as aerial photographs and satellite imageries are interpreted visually. Likewise, digital data products or digital images are interpreted mathematically by using computer software. In this chapter, we will discuss about visual interpretation, digital interpretation, activities of image interpretation, basic elements of interpretation, interpretation keys. Visual interpretation. Both aerial photographs and satellite imageries are interpreted visually. Photogrammetry is a science which study interpretation of aerial photographs. To interpret aerial photograph, a number of sophisticated instruments such as pocket stereoscope, mirror stereoscope, plotter is used in photogrammetry. For measuring area, height, slopes of different parts of earth photographed, and also for plotting different objects, themes from aerial photographs. With the development of science and technology, satellite imageries became more and more popular gradually. Satellite image interpretation is an art of examining images for the purpose of identifying objects and judging their significance. Interpreters study remote sensing image logically and attempt to identify, measure and evaluate the significance of natural and cultural features. Image interpretation technique require extensive training and is labor intensive. Information extracted from imageries is based on the characteristics of the image features such as size, shape, tone, texture, shadow, pattern, association, etc. Though this approach is simple and straightforward, it has shortcomings. The range of the gray values products on a film or print is limited in comparison to what can be recorded in the digital form. Human eye can recognize limited number of color tones, so full advantage of radiometric resolution cannot be used. Visual interpretation poses serious limitation when we want to combine data from various sources. Advantage of visual interpretation is image analyst experience and knowledge is available, and it is a very good for extraction of spatial information, whereas the disadvantages is that it is time consuming and interpretation result may vary with time and person depending upon their experience and knowledge. Digital interpretation. Digital interpretation facilitates quantitative analysis of digital data with the help of computers to extract information about the earth's surface. Digital interpretation is popularly known as image processing. Image processing deals with image correction, image enhancement and information extraction. Image correction means to correct the errors in the digital image. Errors are resulted due to two reasons. When errors are resulted due to the defects in the sensor, as for example, if one of the detector out of n number of detectors does not work, it is called radiometric error. When errors are resulted due to Earth's rotation, spacecraft velocity, atmospheric attenuations, etc., it is called geometric error. Both radiometric and geometric errors or noise in an image are reduced through different techniques with the help of computer. Image enhancement deals with manipulation of data for improving its quality for interpretation. Sometimes digital image lacks adequate contrast. As a result, different objects cannot be recognized properly. So, the image requires contrast improvement. Through different image enhancement techniques, contrast is improved in digital image. After image correction, rectification and contrast enhancement, information are extracted from the digital image, which is the ultimate goal of an interpreter. In information extraction, spectral values of the pixel are analyzed through computer to identify or classify objects on the earth's surface. In other words, spectrally homogeneous pixels in an image are grouped together and differentiated from the other groups. In this way, different features of the earth are recognized and classified. The field knowledge and other sources of information also help in recognizing and classification processes. Advantage are it is a time effective, requires much less time for interpretation, The result can be exactly reproduced for any number of times, and the extraction of the quantitative information is possible and easier, whereas the disadvantages are the image analyst experience and knowledge is not available. It is poor in extracting spatial information. Activities of image interpretation. Detection, identification. This is primarily a stimulus and response activity. The stimuli are the elements of the image interpretation. The interpreter conveys his or her response to these stimuli when description and labels that are expressed in the qualitative terms, example, likely, possible or probable. Very rarely do interpreters use definite statements with regards to describing features identified on aerial photography. Measurement. As opposed to the detection and identification, the making of the measurements is primarily quantitative. Techniques used by air photo interpreters typically are not as precise as those employed by photogrammetrists who use sophisticated instruments in making their measurements. The measurements made by photo interpreters will get you close given high quality, high resolution, large scale aerial photographs and appropriate interpretation tools and equipment. You can expect to be within feet, whereas with photogrammetry, if you employ the same type of photography, the appropriate equipment you would expect to be within inches. Problem solving. Interpreters are often required to identify objects from a study of associated objects that they can identify, or to identify object complexes from an analysis of their component objects. Analysts may also be asked to examine an image which depicts the effect of some process and suggest a possible or probable cause. A solution may not always consist a positive identification. The answer may be expressed as a number of likely scenarios with statements of probability of correctness attached by the interpreter. Basic elements of interpretation. Analysis of remote sensing imagery involves the identification of various targets in an image, and those targets may be environmental or artificial features which consist of points, lines or area. Targets may be defined in terms of the way they reflect or emit radiation. This radiation is measured and recorded by a sensor and ultimately is depicted as an image product such as air photo or satellite image. We choose our sense of depth when viewing a two-dimensional image unless we can view it stereoscopically so as to stimulate the third dimension of height. Indeed, interpretation benefits greatly in many applications when images are viewed in stereo as visualization and therefore recognition of targets is enhanced dramatically. Viewing objects from directly above also provides a very different perspective than what we are familiar with. Combining an unfamiliar perspective with very different scale and lack of recognizable detail can make even the most familiar object unrecognizable in an image. Finally, we are used to seeing only the visible wavelength, and the imaging of the wavelength outside of this window is more difficult to us to comprehend. Recognizing target is a key to interpretation and information extraction. Observing the differences between the targets and their backgrounds involves comparing different targets based on any or all of the visual elements of tone, shape, size, pattern, texture, shadow and association. Visual interpretation using these elements is a part of our daily lives, whether we are conscious of it or not. Examining satellite images on a weather report or following high-speed chases by views from a helicopter are all familiar examples of visual image interpretation. Identifying targets in remotely sensed image based on these visual elements allows us to further interpret and analyze. The elements are tone, color. Tone can be defined as each distinguishable variation from white to black. Tone refers to the relative brightness or color of the objects in an image. Color may be defined as each distinguishable variation on an image produced by a multitude of combination of hue, value and chroma. Many factors influence the tone or color of the object or features recorded on photographic emulsion. But if there is not sufficient contrast between an object and its background to permit at least the detection, there can be no identification. While a human interpreter may only be able to distinguish between 10 to 20 shades of grey, interpreters can distinguish many more colors. Some authors state that interpreters can distinguish at least 100 times more variation of color on color photography than shades of grey on black and white photography. Ground objects of different color reflect the incident radiation differently depending upon the incident wavelength, physical and chemical constituents of the objects. The imagery as recorded in the remote sensing is in different shades or notes. For example, plowed and cultivated lands record differently from fallow fields. Tone is expressed qualitatively as light, medium and dark. In SLAR imagery, for example, the shadows cast by non-return of the microwave appear darker than those parts where greater reflection takes place. These parts appear of lighter tone. Similarly, in thermal imagery, objects at higher temperature are recorded of lighter tone compared to objects at lower temperatures, which appear of medium to dark tone. Similarly, topsoil appears as a dark tone compared to soil containing quartz sand. The coniferous trees appear in lighter tone compared to broad-leaved tree clumps. Resolution. Resolution can be defined as the ability to the entire photographic system, including lens, exposure and processing and other factors to render a sharply defined image. An object or a feature must be resolved in order to be detected or identified. Resolution is one of the most difficult concepts to address in image analysis because it can be described for systems in terms of modulation transfer or point spread function, or it can be discussed for camera lens in terms of being able to resolve so many line pairs per millimeter. There are resolution targets that help to determine this when testing camera lens for metric quality. Photo interpreters often talk about resolution in terms of ground resolved distance, which is the smallest nominal contrast object that can be identified and measured. Size. Size can be important in discriminating objects and features. For example, cars versus trucks or buses, single family versus multi-family, residences, bushes and trees, etc. Size of an object in an image is a function of a scale. It is important to assess the size of a target relative to other objects in the scene, as well as absolute size to aid the interpretation of the target. A quick approximation of the target size can detect interpretation to an approximate result more quickly. In the use of the size as a diagnostic characteristic, both the relative and absolute sizes of the object can be important. Size can also be used in judging the significance of the object and feature. The size of the crown of trees can be related to broad feet that may be cut for specific species in managed forest. The size of the agricultural field can be related to water use in arid areas or the amount of fertilizers used. The size of runways give an indication of the type of aircraft that can be accommodated. For example, if an interpreter has distinguished zones of land use and had identified an area where a number of buildings are in it, large buildings such as factories or warehouses would suggest commercial property, whereas the small buildings would indicate residential use. Shape. The shape of the object or features can provide a diagnostic clues that aid identification. The Pentagon building in Washington is a diagnostic shape. For example, a man-made feature has straight edges while natural features tend not to. Roads can have a right angle turns, railroads cannot. Other examples include freeway interchanges, old fortification and military installations. Texture. Texture is a frequency of change and arrangement of tones. This is a micro-image characteristics. The visual impression of smoothness or roughness of an area can be often be valuable clue in image interpretation. Still, water bodies are typically fine textured, grass medium, brush rough. They are always exceptions through and scale can and does play a role. Grass can be smooth, bush can be medium and forest is rough on a higher altitude aerial photographs of the same area. Rough textures would consist of a malted tone where the grey levels change abruptly in a small area, whereas smooth textures would have a very little tonal variation. The smooth textures are most often the result of uniform, even surfaces such as field, asphalt or grasslands. A target with a rough surface and irregular structure such as the forest canopy results in a rough textured appearance. Texture is one of the most important elements for distinguishing features in a radar imagery. Pattern. Pattern is a spatial arrangement of objects. Pattern can either be man-made or natural. Pattern is a macro image characteristics. It is the regular arrangement of objects that can be diagnostics of feature on the landscape. An orchid has a particular pattern. Pattern can also be important in geological or geomorphological analysis. Drainage pattern can reveal a great detail about the lithology and geologic structure patterns of the underlying strata. Dendritic drainage pattern develop on flat bedded sediments, radial on domes, linear or talus in an area with falls, etc. It must be noted here that pattern is a high scale dependent. Pattern refers to the spatial arrangement of visibly discriminable objects. Typically, an orderly repetition of similar tones and texture will produce a distinctive and ultimate recognizable pattern. Orchids with evenly spaced trees and urban streets with regularly spaced houses are good examples of pattern. Site. Site refers to how objects are arranged with respect to one another or with respect to terrain features. Aspects, topography, geology, soil, vegetation and cultural features on the landscape are distinctive factors that the interpreter should be aware of when examining a site. The relative importance of each of these factors will vary with local condition, but all are important. Just as some vegetation grows in swamps, others grow on sandy ridges or on the sunny side versus the shaded sides of the hills. Crop types may prefer certain conditions. For example, orchids on hillsides. Man-made structures may also be found on rivers, example power plant, or on a hilltop, example observatory or radar facility. Association. Some objects are so commonly associated with one another that identification of one tends to indicate or confirm the existence of the other. Smokestacks, cooling ponds, transformer yards, coal piles, railroad tracks or coal-fired power plant, arid terrain, basin bottom location, highly reflected surface, sparse vegetation, that is the playa, which typically have halophytic vegetation, example salt brush. Association is one of the most helpful interpretation cue in identifying man-made installations. Aluminum manufacture requires large amount of electric energy. Schools of different grade levels typically have characteristic playing ground, parking lots and cluster of buildings. Nuclear power plant are associated with a source of cooling water. Weather patterns can be associated with the pollution sources, etc. Height. For some types of analysis, example landforms, forestry and some intelligent applications, some interpreters believe that after tone, color, height is the most important element for identification. This is a point of debate, but height can add significant information in many types of interpretation tasks, particularly those that deal with the analysis of man-made features and vegetation. How tall a tree is can tell something about the expected amount of broad feet. How deep an excavation is can tell something about the amount of material that has been removed. In some mining operation, excavators are paid on the basis of materials removed as determined by photogrammetric measurement of volume. Shadow. Geologists like low sun angle photography because of the features that shadow patterns can help identify. Example, fault line fracture patterns. Church steeples and smokestacks can cast shadows that can facilitate their identification. Tree identification can be aided by an examination of the shadow thrown. Shadows can also inhibit interpretation. On infrared aerial photography, shadows are typically very black and can render targets in shadow uninterpretable. Shadows cast by an object are sometimes important clues to their identification and interpretation. For example, shadows of a suspension bridge can easily be discriminated from that of a cantilever bridge. Similarly, circular shadows are indicative of coniferous trees. Tall buildings and chimneys and towers, etc., can easily be identified for their characteristic shadows. Shadows, or on other hand, can sometimes render interpretation difficult. Dark slope shadows covering important detail. Visual interpretation keys. Keys that provide useful reference of refresher materials and valuable training aids for novice interpreters are called image interpretation keys. These image interpretation keys are very much useful for interpretation of complex imageries or photographs. These keys provide a method of organizing the information in a consistent manner and provide guidance about the correct identification of features or conditions on the images. Ideally, it consists of two basic parts: a collection of annotated or captioned images, that is the stereo players, illustrative of the features of the condition to be identified; a geographic or word description that sets forth in some systematic fashion the image recognition characteristics of those features or condition. There are two types of keys: selective key and elimination key. Selective key. The selective key is also called the reference key, which contains a numerous examples images with supporting text. The interpreter selects one example image that is mostly nearly resembles the feature or condition found on the image under study. Elimination key. An elimination key is arranged so that the interpretation process step by step from general to specific and leads to elimination of all features of condition except the one being identified. Elimination key are also called as dichotomous key, where the interpreter makes a series of choices between two alternatives and progressively eliminates all but one possible answer. To interpret aerial photograph, a number of sophisticated instruments such as pocket stereoscope, mirror stereoscope, plotter is used in photogrammetry for measuring area, height, slopes of different parts of earth photographed, and also for plotting different objects, themes from aerial photographs. With the development of science and technology, satellite imageries became more and more popular. Gradually, digital interpretation is popularly known as image processing. Image processing deals with image correction, image enhancement, and information extraction. Image correction means to correct the errors in the digital image. Digital interpretation is popularly known as image processing. Image processing deals with image correction, image enhancement, and information extraction. Image correction means to correct the errors in the digital image.